Welcome back to this tutorial where we will make a map for Combat Mission Cold War with CMAutoEditor version 2. Now, part 2 will be about getting the elevation data that we downloaded in part 1 into the Combat Mission Scenario Editor. Okay, before we start with that, let's take a quick look at the data that we downloaded last time. So we had these DGM XYZ files, and so just we get an idea of what the data looks like. Let's open it. Let's open it. Yeah, it's a large file. Yeah, there it is. So this is just a large bunch of X, Y, and Z values. And this is in UTM coordinates X and Y, and so X and Y in meters from the coordinate origin, and this is the Z value, so the actual elevation value, also in meters above sea level, I think, or probably. Okay. Um, Now, this is a huge bunch of data, and what we need to do now is select the data that we are interested in for making this map. For that, let's head back to map.army. Remember last time we had drawn this outline for our map, and in this part we will take this outline and feed it into the DGM converter. Yeah, I mean, as you know, in the scenario editor, you have obviously rectangular maps, and yeah, it's probably hard to see in this video. That's not a perfect rectangle, so it's more like a polygon with 4 sides. What's the word for that? Quadrangle, I guess. Um, but that doesn't really matter. I think I told you last time the tool will take care of that. As long as it's roughly the correct shape, it will do its job. What we should also take care of is the fact that in combat mission there is only one water level. And in contrast to that, in reality, obviously water flows downhill. Um, Now that may not sound like a big issue here for you, but the bigger the map, um, the more important this gets. So, and we are doing a map for Combat Mission Cold War. Okay, it's not that big, but let's say you have a really huge map like 4 by 4 kilometers, and then you can easily have differences in elevation levels from one end of a river to the other end of a river of that map of say 6 to 10 meters. What that means is that in the editor, when you mark this river then as water, you will have the water level on the one side correct, and on the other side you will have a 10-meter deep valley where the river should be, and the river somewhere on the bottom of that valley. That's not something we want to have. So I'll tell you a bit more about how this actually works, but for now let's just mark the start and end point of this river on our map. For that, let's just take a pin and put it somewhere. It doesn't have to be totally exact here. And move there, move there, move there. And another pin here. Okay, right. So what does this actually do? There's nothing really fancy going on under the hood. The tool will merely go and I'll draw a line to make this a bit more clear and calculate a plane going through these 2 points. 2 points. Yep. Um, and in such a way that the values of equal elevation are perpendicular to this line. Yeah, I should learn how to do that with just 2 points. Yeah, so like, mm, not another time. Okay, uh, roughly like so. This time I got it right. Um, so and then the tool will subtract the difference in elevation between this point and this point uh, from here and do linear interpolation in between. So if this is like 6 meters higher than this point, it will make this point sit on the same elevation as this point, and of course this point will also have the same elevation and so on. Usually you won't notice for the rest of the terrain here, but it will just mean that the water level for this end of the river will be the same as for this end of the river, and this will remove this nasty effect where you have then a deep ravine instead of a shallow river. Okay, I quickly removed those lines. We don't need them. And you don't have to care about how this actually works. All you need is the coordinates of these 2 pins, which you can grab like this. And actually, that's it. So now let's go ahead and start the data conversion or extraction. Let's just quickly move the browser to the side a bit. Yep. And then start DGM to CM. All right, what do we have here? So first of all, we have to select the folder in which we stored the elevation data. We do it like this. And we just select the XYZ folder. Select folder. Yeah, and then we have to give the coordinate reference system of the data. So that's basically a code that says what those values, especially those x and y values actually mean. So you saw those were some large numbers, and I told you they were with respect to some coordinate origin, and this code, among others, tells us what this origin actually is and what kind of a projection from the globe to a plane is and all that. Quick interjection, how we could have obtained this CRS code. There are different ways how to get this, and usually you get some kind of information with the data you download, or on the page where the data is provided. In this case, we have in our XYZ folder, there's another folder, DGM1 meta. And let's just click on this. Okay, and there is one column, Koordinatenreferenzsystem, which just is a German translation of coordinate reference system. And it's this ETRS 89 UTM32. With that, we can just head over to Google and look for that. EPSG code ETRS 89 UTM, for example, and we get 25832, the number that was entered there. File output name, let's call it AGA. That's just a prefix for all the stuff that is going to be created soon. And we also have to give the tool another CRS value, meaning in this case, so we want to give the tool the points that make up this almost rectangle, and of course we also have to tell the tool what those points mean, and here those are latitude and longitude values, and the code for that here is 4326. You can usually use just this code if you use latitude and longitude values. Okay, now we have two options here, axis parallel or freely rotatable. Axis parallel, in that case, just the lower left and the upper right point would be enough, but we want to have this rotated rectangle. So instead we go to freely rotatable. And so then we have to give it 4 points. And there's just one thing we need to know. As it says here, the line between the first and the second point we give the tool will be the west to east axis in combat mission, and the lower one. So if we select this and this point as the first points, and we should do it counterclockwise, by the way, then this will be the bottom of the map, and yeah, so the south side, east, north, and west. Okay, so now how do we get those values? That's quite easy in map.army. We just select this rectangle and we go to this button here, and there we get all the points. So let's just see. Yeah, so we will have this axis here as the bottom line. And one thing that we should note, this is a big, that's a bit of a convention thing here. Often it's latitude, longitude, and sometimes it's different. I use a different convention because I like to have it X and Y, and that actually means you have to do it longitude, latitude. So we'll start with this value and then for X, and that's the Y value. Okay, so we want to have this point first, and if we click on it, we see that this here is marked. So we take that and just put it here. We take this one and just put it here. Okay, next point, we click here and we see this one is highlighted. That's exactly what we want. this here, and this here. Next, no, we want this one up there. Here. And here. And the last point is this one here. And here. So, and in addition, we want to apply water level correction. So we check this box here. Again, the CRS value, it's the same as for the coordinates up there. And then we know we need 2 more XY value pairs. The lowest point in the river on our map is this one down here. We can do it in the same way. This one and this one, and now the upper one, this one, and this one. And okay, we're done with that. Let's do a quick scan if we have everything correct. Yeah, it looks right to me. So let's just hit Start DGM Converter and take a look what's happening here. Okay, processing input data. And it's again quite a lot of data, and it will take a bit of time to process that. So it's first reading in all the data there is in this XYZ folder, and now what's interesting, so it tells us, okay, we wanted water level correction, and the difference between 2 points, between those 2 pins we had, is already 5.6 meters. So that's really significant. And we would have seen that if we didn't apply the water level correction. Okay, now this will take a bit of time, and in between the tool will output a lot of files. Yeah, they are all stored in this folder. That's maybe not so awesome, but since they all start with the same word, we can easily grab them later. We can just quickly look at the pictures it already created. So the original picture, that's this one. And so we see a height map here, or a heat map. Let's put it this way. And this is the whole data folder that we gave it. So that's all the data we downloaded. And the elevation values are color coded. So blue is less, and this green yellow thing is more. And again, this is the outline that we selected. The yellow dashed line is the original polygon that we gave it, and the solid red line is the correct minimal rectangle that includes this polygon that we gave the tool. Okay, that all looks the way it should. So we have this western hill here, we have this eastern hill here. If you look closely, we can see the line of the river going here. It's a bit darker than the rest. And what we see here, that's the railway that goes through the hills here. Yeah, that's about what we can see from there. Okay. Then we have what's interesting. Yeah, the rotated thing here. Let's take a quick look. Yeah, so And here you can see the way this rectangle was rotated such that we have an axis parallel rectangle now. So this is the way it will look in the Combat Mission editor. Yeah. Okay, and in between, maybe you saw it. Yep, we got the message DGM conversion complete. So the tool did its job, and as I promised, it gave a lot of data, produced a lot of files. So there are, let's click OK. And those files are not small, but they are necessary for the most part. There's two important things. This year, this CSV file, that's the actual conversion that was made. Let's quickly open it. Okay. And this is just X and Y in units of combat mission squares, and that's the corresponding elevation value. And if we go down to the bottom, not that fast. Scroll, yeah, we see that it's so it starts with 191 by 241 squares. Okay, and there's some additional things here. There's those there are those grid files here, and that's a bit of a convenience thing. So we have this grid that represents our squares in the Comet Mission scenario editor in this rotated fashion, and those grids are stored in files so that we can use it later on. So that it's just stored as geometric objects. There's the actual squares, and there's two more that there are two more grids that are used that are a diagonal version of it and a smaller version of it. And those two grids are basically used for placing houses later on. Okay, I quickly went ahead and moved all the data that we just produced to a dedicated folder so that this doesn't look too confusing here. Now we're done with that. We can just open up CMAutoEditor itself. Let's do that. Here we go. And yeah, if you don't know about it, let's quickly go and read it. So yeah, it says if you haven't done so yet, I'll open up the scenario editor. I've already done that. And if you want to set elevations, go to map elevation and click direct. Okay, let's do that. Go to elevations, click direct. Go back. Okay, we can ignore this part. Make sure the map size is 320 by 320. Or check take start size from file, but only when continuing a map. We don't do that, so 320 by 320. That's the standard size when you create a new map. Okay, check. And yeah, once you are ready to start, just click Start CMAutoEditor. We are not ready yet. We have to actually select the file that we want to feed it. So let's do this. No, we don't want the example height map. but we want to have what we just produced. I stored it under elevations, and we'll take this AGA file. By the way, there's a contour file pro produced alongside that just gives you the elevation data along contour lines only. That's a bit of a legacy thing, and it's not all that useful. It just saves a bit time if you don't want to set all the elevation values, or just want to get a quick impression of how it looks. But let's take the correct file, open. Yeah, and then we just click Start CMAutoEditor, and you can see the countdown going on, and we move back to here and see what happens. All right. So you can see we are now working in the smallest map size possible, and so that has to do with that the clicking could actually be much faster, but the editor isn't, let's say, infinitely responsive. And the smaller the map, the less calculations it has to do, and the faster we can do the clicking. What else do we should we note? You can see there's a margin on three sides that's not relevant for elevation data, but it will be relevant when we import OpenStreetMap data. It's mainly for putting houses there, which we couldn't do in cases where houses are on the bottom or top row, for example, or the rightmost column. In that case, the editor would just refuse to put a building there, and then we couldn't use the small map size thing. Okay, this will take a bit of time. I did a quick look of how large the map is. It's roughly 2.8 square kilometers, and at least on my machine, you can roughly count it's like something on the order of magnitude 20 minutes per square kilometer. So we'll have to wait for something like an hour. So I guess you have enough time. Well, I have enough time to grab a coffee or three in between. And I'll restart the video once we are done with this. Back again. 1 hour and 11 minutes. I slightly missed the mark, I'm afraid. I'll have to update my calculation, it seems. Anyway, we are done, and so let's take a look at the result. Before we do that, maybe I should start the timer again, because in the comments on my last video, I read the concern that setting an elevation point in each square might increase loading time. And so just to measure what the loading time for this year is, let's take a look. Yeah. I think that was really quick, like 6 or 7 seconds. And this map is 1.5 by 1.9 kilometers, so not super small. And so I think I can safely say that that doesn't really influence loading time much. Okay, um, let's look at what the result is here. Yeah, so this is the view from south to north. Yeah, I think in reality north is somewhere in that direction. Anyway, yeah, so this should be the river. Yeah, you can nicely see it here. Uh, So then we have this structure here. That should be the Bundesstraße. It is slightly elevated compared to the surrounding terrain. Hmm. And yeah, I mentioned it already. This here, it was clearly visible on the heat map for the elevation data. This is the railway line. We'll put a bridge here later on, and yeah, it goes straight through the hill here. Yeah, yeah, that looks nice. Okay, maybe. Yeah, let's zoom out a bit so that we can see all of it. I think this here is probably going to be, should be a stream or something. Will be interesting to see what it is. It's a bit sad that there is this cliff structure here. In reality, this is all forest here. But well, we'll have to live with that. Not too bad. Okay. Um, yeah, before we finish this part, maybe let's do a comparison in Google Earth. Let's go here. Remember, our village was called Aga, so it's actually close. It's part of Loma. Let's go there. Maybe I should have done that at the start of this tutorial series. Okay. Um, let's see. Yeah, I mentioned this golf area here. That has to go for our map. Mm. Um, yeah, I think there are a few features that you'll recognize. There's this river here. There's the Bundesstraße. Um, the railway line that's here. Here's the bridge I just mentioned. This is the small industrial area. And yeah, as I said, there are trees almost everywhere here. Well, you can't have everything. Mm, okay. For final comparison, let's take the same perspective as in combat mission. Should be roughly this here. Yeah, we were looking straight along this road. Okay, and let's go back to commit mission. Yeah, I think you can see that this is quite similar. I mean, of course, we are missing the hills further along this direction, but yeah, here's the river, Bundesstraße, here are the hills. Um, let's go back. Yeah, same hills here. Yeah, I think this map is really going to look nice later on. All right, I think that means we are done with this part of the tutorial. Yeah, in the next part, I guess there's what most of you were looking for or waiting for. Um, there we'll take a look at how to import OpenStreetMap data and make the map more looking like Google Earth than just this bare terrain here. Okay, yeah. Um, what should I say? If you liked what you saw, please consider subscribing. I mean, hey, uh, if I understand it right, you need 1,000 subscriptions if you want your work monetized. So, when last time I looked, I just needed another 997. So, we'll see what comes out of it. Maybe afterwards I need 996. Wouldn't that be awesome? All right. I guess I'll see you in the next part.